start a new topic, cross product or vector product of two vectors. So earlier we have seen one such product which we called scalar product or dot product, where two vectors were giving a quantity which was a scalar in nature. For example, work done, force dot displacement we got as a scalar product. So it was A dot B, magnitude of A into magnitude of B, and then cos theta, where theta was the angle between these two vectors. Okay. In component form, if we write these two vectors, this will be Ax, which is x component of vector A, and then so on. And dx, I cap plus dy, j cap plus b, z, k cap. Okay. So after doing dot product, only I dot I term will sustain, I dot j and I dot k will be 0. So ax dx plus ay. Similarly, z dot j will only sustain here, dy plus az dz. Now there is situation where two vectors can give a vector quantity as a result of product. So here what happens? Magnitude of vector A times magnitude of vector B, instead of cos, here we have sine theta, and there is unit vector. And this unit vector is along, okay, let me draw coordinate axis here. So let's say this is x coordinate, this is y coordinate, this is z coordinate, and let's say there are two vectors, vector A and vector B. So this is vector A, and let's say this is vector B, and these two vectors are lying in plane xy plane. So A cross B, this is angle between these two vectors, theta. So A cross B will be along this direction, which is perpendicular to the xy plane in this particular case, that is along this positive z direction, and this is the direction of this unit vector n cap. And another way you can write A cross B, this is cross product of vector A and vector B divided by the magnitude of this vector. This quantity is unit vector n cap. So the direction in which A cross B lies is the perpendicular to the plane in which these two vectors are lying. And you can understand this thing by using this diagram also. Let me show you the diagram. So here we have the diagram of the vector A cross B, and you can see if you are doing vector A cross vector B, so you can get the direction of vector A cross B by using right hand. And here what are you doing? You can just curl your these fingers, and then the direction in which this thumb is pointing will be the direction of A cross B vector. So you have to stretch open your right hand like this, and then you have to excuse my drawing here, but what are you doing? You can place this right hand and this four fingers in the direction of vector A, and then you can curl it towards vector B, and in this scenario your thumb will indicate the direction of vector A cross vector B. And you can understand it in another way also. Here right handed screw is there. So what happens when you twist or rotate this right handed screw? It moves in a direction this way, and the twisting will show you A cross B, means you are twisting it from A, or you are rotating it more precisely from vector A towards vector B, and then the movement of the tip or the movement of the entire screw, if it is placed inside something, inside let's say a wooden block, so the movement of this screw, right-handed screw, will give you the direction of vector A cross vector B. Okay, now let's move to study some properties of this cross product or vector product. So what happens? This vector product is not commutative in nature, as dot product was commutative in nature, like A dot B was equal to B dot A, but this is not the case here. A cross B is not equal to B cross A. Rather, A cross B is equal to negative of B cross A. What does it mean? It means A cross B, suppose this is vector A and this is vector B. So A cross B is this vector which is perpendicular to the vector A and as well as to the vector B, A cross B. But B cross A will be, now you are moving towards this to this. So this is the direction of vector B cross A. And this B cross A has the same magnitude as the magnitude of A cross B, but the direction of this B cross A is just opposite. That's why here negative sign is appearing. Now, what is its behavior under reflection? Okay, so if we are saying that A cross B is the cross product of vector A and vector B, so what will be the cross product if we are taking their reflections? That is, instead of vector A, we are taking vector negative of vector A, means just opposite in direction, equal in magnitude, a kind of mirror image, and cross minus B. This is ultimately going to give you A cross B. Means under mirror reflection, this vector A cross B remains invariant. Such a vector is called axial vector or pseudo vector. Okay. So more about axial and polar vector you are going to study in higher classes. So here we are restricting ourselves up to here only. Now, what about commutative? So we know A dot B plus C, we can write A dot B plus A dot C. And in case of cross product, it holds the same way. So A cross B plus C is A cross B plus A cross C. That is, cross product is commutative over addition. So this is one thing. Now moving to a few more properties. What about we are doing cross product of a vector with itself? This should be 0 because look, this is A into A sine, angle between these two vectors will be 0. So ultimately this is 0, kind of null vector. And here we are taking null vector because look, we know that this cross product is going to give you a vector result. So if there is nothing to keep it compatible with this convention, we have to introduce this null vector concept, means a vector with 0 magnitude. Now let us study the cross product of unit vectors in Cartesian coordinate system. So we know that we have three coordinate axes. This is x, this is y, this is z, and we choose I cap unit vector along x and j cap unit vector along y and k cap unit vector along z. And of course there are other three. Along negative z it is minus k cap, along negative y it is minus j cap, and along negative x it is minus I cap. So we are going to do cross product of these three unit vectors in different ways. Now what will happen if we do I cross I? So we know the angle between unit vector I and itself will be 0. So ultimately we are going to get a null vector here. Similarly, j cross j will be, and k cross k is also going to give us null vector only. Now, what about I cross j? I cross j. It will be magnitude of vector I, which is 1, because this is unit vector, its magnitude is 1, and magnitude of j vector, which is also 1. So I am writing only angles, because one into 1 will be the same. And then what is the angle? So sine 90 degree, and there will be n cap, and we have to obtain this n cap also. Sine 90 is 1, so the cross product of vector I cap and vector j, this is going to give us another unit vector, and we have to find out its direction. So if we are doing I cross j, the resultant vector after this cross product, or the product we are going to get along the positive z direction using that right hand screw rule. And then we know that this n cap is unit vector, and unit vector along this positive z direction is nothing but k cap. So to write it clearly, we can write I cross j equals to k cap. Now what about j cross I? I'm just doing it in opposite way. So j cross I, this is also going to give us a unit vector, but that unit vector will be just opposite to this k cap, that is minus k cap. So here we have cross product of two unit vectors in Cartesian coordinate system. And similarly, we can continue the argument for j cross k. And we know j cross k is going to give us now I cap, and k cross j will be minus I cap. And one more there we can take here, k cross I, you can check it by yourself. This will be j cap, and I cross k will be minus j cap. So in this way, we can obtain cross product of these unit vectors. And now we can do one thing here. Let's take a circle to keep it fairly simple in mind. Let's say we have drawn this circle. This is I cap, this is j cap. These are just notations to keep these things in mind. K cap. So if you are going to do I cross j, the resultant vector will be k cap. This is what to remember. So if we are doing cross product of I and j in this direction, so it will give us k. In the same way, if we are doing k cross I, the resultant will be j cap. And similarly, j cross k will be I cap. So, and if you are moving in opposite direction, it will be with negative sign. For example, I cross k will give you minus j cap, or j cross I will give you minus k cap. Okay, let's move to the next point. Now we are going to do cross product of two vectors in component form. So earlier we have done it, and we have obtained this thing. Okay. Let me get you back to this point. So A cross B is here. What is the A cross B? Yes, A cross B is here. So it is AB sine theta and unit vector. Now, what if we write A in its component form in this space, means A in terms of its x component, y component, and z component, and B is also written in the same format. So then what will be the A cross B? So we are going to do that now. Okay, let's get back to a fresh page. Here. Okay, so what will be A cross B in its component form? It will be ax I cap plus ay j cap. I have resolved this vector A into its components, and then we will have bx I cap plus by j cap plus bz, or you can say bg k cap. Now x I cap cross this bx I cap and I cap will give you cross product, will give you 0 null vector. So we are not going to write this thing. Okay, let me write it here only. Now this with this term, so it will be ax by I cross j is going to give you k cap, and then ax bz Ax, Bz, and I cross k, and I cross k will give you minus j cap. Okay. So if you know this thing, you can skip this part or you can just fast forward this thing. Now ay j cap multiplied with this. So ay bx and j cross I, which will give us minus k cap, plus j cross j, this is going to give us 0, and j cross k, this is okay, this is going to give us I cap. So ay bz I cap. Now az k cap, az and bx, k cross I, it is in order, so it is going to give us j cap. Then az by and k cross j, this is minus I cap and plus 0, k cross k. And now let me bring these things in a more compact way. So here is I and here is minus I. So let me take I cap common here, and then we will have ay bz minus az by plus, this is not power, this is multiplied. Okay. Second, let me write for this j cap. So here we have j cap and here also. So we can write j cap here, and then this is az bx minus ax bz. And then what about this k cap? So here we have k cap ax by, and where is another? Here ay bx negative ay, okay, ay bx. Okay, let me write it in a proper format where I am going to do something with it. Okay, az by I cap. Let me write it minus here. Then it will be ax bz minus az dx. Soon you will come to know why I have written this negative sign here. And then we will have ax by minus ay dx k cap. Okay, so moving ahead. Now this thing you can write in the form of determinant. So it will be ay here, and then bz, and then az here, and then by here, and I cap minus ax, and here bz, then az will be bx, and then we will have multiplied with j cap, and again we can write this thing x, here by, and then ay, and here bx, and k cap. And if we move ahead, if we want to combine these three, okay, you should not be worried about this thing, you can do it other way. I'm just explaining how can you do. So look, this is I cap multiplied with this thing. So ay az by dz. Now this is minus j, and it is multiplied with this thing, so we have to eliminate this and this round here, and then we will have ax dx here and az bz in this row, sorry, in this column. So it is already here. Now checking for this k cap. So for k cap we have to eliminate this thing, so ax by and bx ay is there. Ultimately we have reached in a situation where we have obtained this cross product a cross b. So, and now you can go other way, and you can start from here, and then you will move in reverse way here, and you can reach up to this point. At least you can reach up to here, and this is what we were obtaining from a cross b already. So if you are not comfortable with moving in this way, you can check whether this a cross b is coming equal to the determinant for. So this is all a lecture part for this concept.